And there's Dave with full safety gear on, face shield and goggles, measuring up the steel compression sample that he's going to start with. Here's a nice view. We can actually kind of see the numbers here. You can see the big 1, so it's at least 1 inch. But you can't see the 1.1, so it looks like this is 1.092-ish, 1.092. And so finally the camera resolution is good enough to see that number. So 1.092 for the height of that thing. Dave's going to write that down. And then next up, I'm going to guess he's going to measure the diameter. And now he's going to measure the length again.
And diameter is?
Nope, diameter. Right, we already measured the length. So he slides it all the way over that way. And what can we see there? I see the 7. I can see a little bit of the 8. And if I can see a little bit of the 8, that means I can probably see the whole thing. So it's about 0.842, something like that. 0.845. And you went a little faster than I could read. So now I've got the dimensions of our specimen. We're going to load it up on the 60 kip. 60 kip is 60,000 pounds. Hydraulic load frame, and so now he's going to use the electric motor to raise the crossbar and the crosshead. Now remember with this one, the crosshead moves up and down to make adjustments, but the load is actually applied by the table beneath. There's some marks etched on the table to help us get things aligned so they're right in the center. And Dave is working hard to get the little base piece of metal, kind of a sacrificial intermediate piece of metal there because we don't want to damage the table. And then he sets the test specimen in the middle of that, and then finally puts another sacrificial piece on top. And now we've got a little steel sandwich that we'll compress using the hydraulic table, the piston that pushes up the table. Now remember how this works from the last one, where we're going to pump oil into the cylinder, and then when we stop the oil from returning from the cylinder, that means the cylinder has to expand, and that pushes the table up. So right now he's just getting the follower. Remember, there's a red needle that follows the black needle. The black needle indicates the instantaneous load. The red needle just follows. But it actually doesn't follow, it gets pushed along. And the reason it gets pushed is so that if the load drops, the follower stays where it was. Right? And he's got it turned up to the 60,000 pound scale, and now he's making sure that that valve is closed, so we're not supplying any oil to the piston. And he's going to open that valve and make sure that valve is open so oil can return. Right? So if we're not supplying, but we're allowing the oil to return, that means we can't be raising the piston. So now he's going to lower the table down until it just touches. But the motors aren't strong enough to really apply a lot of load. We don't want to load them up that way. We don't mind loading up the gears on the crosshead to carry some load, but we don't want to give it. Oh, yeah, there it was. You can see he gave it some load with the electric motor, and now he's going to lower it back down, or raise the crosshead back up, actually.
You can click on start.
So there's just a little bit of load, maybe just a little bit, a couple thousand pounds of load on that specimen. There's Ed working the camera back there. He's going to get a really nice view of that specimen. So when the steel comes out of the steel mill, it's got a bunch of iron oxides, some oil oxides on there called mill scale, and that's what gives it that darker color. And so Ed's got the camera zoomed in nicely there, so we can see changes in shape, as well as when it starts to flex, the first thing we'll see is that mill scale, which is very brittle, start to fall off. So I think Dave has the return valve closed now, and he's very, very carefully, very slowly trying to open that supply valve just a crack. He wants just the tiniest trickle of oil to flow into that cylinder so we can raise the table very, very slowly. And remember how rigid that little piece of steel is. So he's controlling basically the speed of the table with the flow rate of oil into that cylinder. Crosshead table, there's the test specimen down in there. Still no load, or no increase in load. So it could be that we're still pushing some air bubbles out, or the square sacrificial pieces aren't totally aligned with the table, so there's a little slop that's going to work out there. Yeah, so this is Dave's first time running this machine, so he's looking back nervously at Rahul, who has, of course, run it hundreds of times. But it's very, very nerve-wracking. There's a lot of force there. Not a lot of power, right? It's just a trickle of oil, but a lot of force. And he just wants the tiniest bit.
Slightly open the loading valve. And now we can go.
Because once it's fully, once everything's firmly in contact, it doesn't take much motion of the table for that load to increase a lot. So he's being cautious. It helps just give it some taps, but everybody develops their own technique. Okay, watch the needle very carefully. Watch the black needle. The red needle already moved, and that's because when he was lowering the crosshead with the electric motor. But watch closely. Looks like he's getting close. Just by his body language, I can tell that he's getting close to. Yeah, now the needle's moving a tiny bit. Slow load is increasing. Whoa, there goes load. Slow down, Dave. Slow down, Dave. Yeah, now he's nervous. But he knows everything's in contact now. There's no gaps. So he's got that valve opened just enough so that needle is creeping upward. The load is slowly increasing. Remember, this is on the 60,000 pound scale. So every full turn is 60,000, every half 30, every quarter is 15. So he's already at 25.5, almost 7,500 pounds there. And if you recall from the acrylic compression experiment, we saw that it reached a maximum load, and the load actually dropped a little bit. Now we don't have a nice digital data acquisition system on here, so it's purely analog, old school. It's like listening to old rock and roll on vinyl records. 7,500 pounds.
And as of now, the brittle outer coating is
Experience tells me that this will yield around 21 or 22,000 pounds. We've got a ways to go. But when it starts to yield, we expect the load to drop slightly. And the way we'll see that is that the black and red needles will separate. Right now the black needle is pushing the red needle along. When the load drops, the black needle drops, but the red needle stays there. So that's kind of what we're looking for. But it's oftentimes very hard to see. So we'll see what happens here.
And single statement you have the voice speed in the cameras, and you can say
16,000, is that, yeah, 15,000 pounds there. We're quarter of the way around the circle, 17.5. We're watching for mill scale to start to flake or crack. Also watching for a slight change in speed of the load increase. Remember, this is constant displacement, and so the load is going constantly until it starts to yield. It should happen pretty close to there. Sometimes you see a big gap, sometimes you just see a little wiggle. Yep, maybe there. So that was 25,000 pounds or so. And if I look at the specimen in the lower left, not a real visible change. Sometimes this experiment is, well, the fact that Rahul is zooming in tells me that maybe they did see something. Yeah, it doesn't show up well here. Some cracks in the mill scale, slight bow to the sample. This thing might be starting to yield. So now we're at 30,000 pounds. This is well past the yield stress of steel. But as it yields, what happens? Right? In tension, the cross-section got smaller and smaller and smaller. We call that necking. In compression, the cross-section gets bigger and bigger and bigger. Barreling. And so as the cross-section gets bigger, and that actually increases the denominator of the stress, right? So the stress, there you can see some cracks forming. Cracks have formed in the mill scale. So now we're 35, nearly 37,000 pounds. But as the cross-sectional area increases, the stress doesn't increase as much. So it becomes pretty non-linear.
Ed, do you want to play? Ed, do you want to play with the
I'm not sure what
loading
Dave
valve?
saw there,
Do you want to play with the loading valve? No? Okay.
but just the noise of that hydraulic pump
Dave, you can play with the loading valve.
sneaks
You
up
can
on you. So
slightly
the noise
open
gets
and
louder
close
and louder
see
and
if you
louder
see anything.
as the pump has to work harder and harder and harder to keep a constant flow of oil flowing into that cylinder. Remember right now, pump. Oh, was that a little wiggle? That seems too high for a wiggle to have happened way up there.
Once you're done,
That would be
you can go to
45,
50,000 and then
40,000 pounds, 39,000
when
pounds.
to 50,000 you can close the loading valve
Unless a crack
and
formed
open
in
the
that
release
steel
valve.
somehow.
Once
That
you're
can
at
be a little
50,000
scary.
and give a thumbs up.
Yeah, so I guess Dave is going to call it maybe at 45,000 pounds. Imagine that you could take your car and 10 of your friends' cars, maybe 11 or 12 of your friends' cars, and all pile them on top of that piece of steel, and they would not crush it. It's an incredibly strong material. We take it for granted. Oh no, Dave's still going. 45, 50. 50,000 pounds. One of my favorite things to do is to crush pennies in there. It's truly illegal, but it's kind of fun. If you have a machine like this, you should crush something. So now what Dave did is he shut off the supply. He's no longer supplying new oil
And now you
into
open
that
the
piston,
release
so
valve.
it's no longer moving. And then he'll crack that valve loose, and that allows all the oil to flow out. And so you can see that load drop all the way back down. The table is just falling,
Zero.
fell all the way back down,
Now you can click on stop.
so there's no load left. Now, huge relief. Yeah, you don't realize how loud that pump gets, but that white noise, that background noise sneaks up on you. So if you're going to do experiments in here all day long, you definitely want some ear protection on. It's exhausting. It's very fatiguing to listen to that pump noise all day.
Now you can remove the steel specimen.
So he uses the electric motor to raise it back up. We did some work on this, so for those of you taking thermodynamics, there is without a doubt work done, and it's
There
warm.
will be some flakes
Some of the
in
mill
bottom.
scale flakes off there. That brittle mill scale fell off the ductile material. There's some indentations on the ends of the sample. We're going to compare that sample to the original shape, I think. Oh yeah, there's the, yep, definitely shorter, definitely squatter, a little bit like me in the past 20 years. And that's it. So the steel's a little less interesting. We're hopefully getting some new machines,
Guys, thumbs up.
but for now that's what we've got. That's the end of compression.